In this HVAC training video, I'm going over 3 methods to test a run capacitor to see if it's bad or degraded. The first test is a capacitor under load test, and it's really important to do that safely with the multimeter. The second test is with the wires disconnected from the capacitor and the capacitors discharged. The third method is a visual inspection. So I'm going to be going over several examples of each scenario, and it's really important to test a run capacitor because if it does fail, it's going to do damage to the outdoor fan motor, the compressor, and if you have a bad capacitor at the indoor unit, it's going to do damage to that indoor blower motor because the blower motor needs the capacitor to start and to run. So that blower motor is just going to overheat and it could potentially fail. So it's really important to test these to see if the capacitor is degrading and to replace the capacitor before it goes bad. And if you want to learn more about HVAC, make sure to join our HVAC Online Academy at acservicetech.com/academy. We've got tons of courses there. We've got certificates for the hours of training, and you can complete it on your time, on your device, on your phone, tablet, laptop, whatever's convenient for you. And also make sure to check out both of our books. This is everything I want you to know about mini split systems, so the electrical side and the refrigerant side. And this is everything I want you to know about air conditioning systems and about refrigerants. All the new refrigerants, all the new tools. So make sure to check these out over at acservicetech.com/store and also on Amazon. Now we're going to get into the video. To test the capacitor at the outdoor unit, we need to remove the shroud, and we're going to first pull the disconnect so we don't have any power, and we're going to loosen these up here. And then we're going to remove both of these screws. You want to make sure to hold this to make sure that it does not fall down onto the line set. We're going to be performing a capacitor under load test. So we're going to start by measuring for voltage, and that's voltage for alternating current. For the sake of safety, we're measuring and making sure that we do not have any voltage present at the outdoor unit. And so we have our disconnect in the off position right now, so we can go ahead and kind of pull at the wires right here. I wanted to show you that this is going from the contactor over to the capacitor. And so we're going to need to measure with one of our probes on here and also on this blue wire because the blue wire is attached to the HERM. So that's the hermetic compressor. So this is going to the start tap on the compressor. And so we're going to be measuring the voltage. You can measure it here or you can measure it between here and here. We're also measuring our amperage right here on this start wire, which is the blue wire for this case. And on our multimeter, we're able to measure amperage and voltage. What we're going to be doing is we're going to take the voltage and amperage, we're going to put that into a formula to determine what our actual microfarad reading is, or our microfarad capacity is, while this is active and running. And so it's really important to be utilizing these alligator clamps on the probes. We don't want to be near this unit while it's running and drawing that amperage because that's a dangerous situation. We don't want to be in here near the wires pulling at our probes or anything like that. So we're just going to go ahead and get these set up ahead of time. So for this test, we're going to take the amperage and voltage, put it into the formula to see how close this capacitor actually is to its rating, which is 35 microfarads. I'm going to give this a signal of 24 volts from the indoor unit, and then after that, I'm going to push our disconnect in, and we'll take our measurements. So we're measuring 4.9 amps and 366 volts. So the formula is microfarads equals amps times 2,650, and so you divide that by the voltage. So we do have the power off right now, and we take our 4.9 amps times 2,650. Now some people will use 2,652, some people will use 2,654. I just round it because it's really not going to make much of a difference. It's 2,650 is what I use. So then we take that, and then we divide that by 366. So that's our voltage. And so you can see that our live capacitor capacitance rating is 35.48. And so that capacitor is good. So now what we're going to do with the power off is we're going to switch this probe over to the fan. So this is the fan wire right here in the back on the capacitor, and we're going to leave this one right on the common because it's attaching right over to here. So you just got to remember that as long as we're plus or minus 6% away from whatever our rating is, the capacitor is good. We are looking for, say, the same or maybe higher, because what may be happening is the plating on the inside of the capacitor may be getting corroded or broken, or just the dielectric has worn down or something like that. So as a capacitor maybe gets older, it might be, say, 34.5 or 34 microfarads, and the compressor will still run. But the problem is, once you get down to a low capacitance rating, like 10 or even 0, we're going to be doing damage to that compressor, and so that will be a problem. So our higher MFD rating is for the compressor. On these dual run capacitors, the lower number is for the condenser fan up top. So this condenser fan is looking for a capacitor rating of 5. Now this time we need to switch out this blue wire, which is right here, with our brown wire. And so we can see it's kind of tangled around some of these other wires, and so what I'll do is I'm going to just pull this up. We want to make sure that this wire is away from the other wires, because there are other magnetic fields and we don't want them interfering with our measurement right here. So once again, we have the power off, so that's why we're safe in here presently. And just to show you that, we're reading 0.2, so we have no voltage here. You don't want to be anywhere near here, especially when it's turning on or when the current is being drawn. Now let's go ahead and send a 24-volt signal from the indoor unit, as well as push our disconnect in. So you see we're measuring 0.78 for our amperage, and our voltage is 320.6. So you see that we have 0.78 times 2,650, and so that equals 2,067. Now we take that and we divide it by our voltage, which is 320.6. And our capacitance, our live capacitance measurement, is actually 6.4. So that's a little high. Now that microfarad reading is technically impossible unless the manufacturer mislabeled the capacitor. And so you don't typically have much more than the rated MFD capacity. So typically you would end up having less. So now for a better accuracy, since I'm noticing the measurement is off in this case, what I'm going to do is I've wrapped this fan wire around the multimeter 3 times. So what we're going to do is we're going to take our measurement and we're going to divide it by 3 in order to then get our amperage, and we're going to run this formula again. So we already know what our voltage is. Now we just want to remeasure our current, because the current was a little bit low. So that's why I'm just doing this. I want to just double verify for accuracy's sake. So now with the power off, we're going to take 2.01 amps. We're going to divide that by 3, and you see we have 0.6 amps. So 0.6 amps is actually less than what we measured when we were just measuring a single wire. And so we can take that times 2,650, and then we're going to divide that by the voltage that we just previously measured, which was 320.6. And you see that we have a microfarad live measurement of 5.53, which is much more accurate. So in this case, you can see that measuring the lower current by wrapping it around several times was more accurate than just that single rep. So this capacitor is good. So If anything, if you read a measurement that is lower than the, say, the 5 UF, such as like 4.4 or something like that, then we would want to replace this capacitor. Or maybe it's 4.5 or something like that. That means that the plating is starting to wear down on the inside. But we're pretty close to 5 here, so this capacitor is good. Now this is one way to check a capacitor during preventative maintenance. So we know that the compressor's running, the fan's running, so we know the capacitor is fairly close, but we want to just check it. So you could check the live measurements. Now you can check the non-live measurements of the capacitor. So what you could do is with the power off, so you could pull the disconnect and verify there's no voltage here. You could take a picture of the wires at the top. Then you could remove the wiring and you could put a resistor across the terminals in order to make sure that the voltage across here, the potential voltage is 0. Then you could switch this over to the capacitance function and we could measure the microfarad capacity of the capacitor. The other thing is if this system is not running and you suspect the capacitor as being bad, then you would be turning the power off, measuring for voltage, making sure that there is no voltage, and then you would be removing these wires and testing it with the capacitance function because you know that the system can't even turn on. So that would take a little bit more initial diagnosis, but I'm going to show you what our next step would be. Next, we're going to do a bench test on these capacitors. And I'm going to show you some of the scenarios that you could run into when measuring these. And so this is considered a bench test or a non-live test. So we're going to set our multimeter on capacitance. And so you can see right now it says mega ohms. So we're going to hit the select button until we get to the UF, or it's actually microfarad, so micro F. And the other thing is I wanted to show you these. These are 2 watt, 20,000 ohm resistors. You can get these on Amazon, they're real cheap. And so you just crimp it right into a wire with 2 spade connectors, and we use that to discharge the capacitor. Now these here are dual run capacitors. They've got 3 tab sets, and these ones are single run capacitors. And so they only have 2 tab sets. And so it doesn't matter which probe you put on what when you're doing your test, but I'm just gonna go ahead and show you one at a time. So here we have the top of 2 capacitors. You can see our common right here, our HRM right here, and the fan right here. And so if we want to go ahead and discharge any voltage off of the plates inside the capacitor, we can just go ahead and put this on there, and then we can just give it a, maybe 20 seconds or something like that. And really, the meter may be able to discharge it, but you're just going to be waiting longer for your measurement. So it's better to just do it this way. And some people try to discharge the capacitor with a screwdriver. Really, what's happening is you're balancing the amount of electrons from one plate to the other plate, and that foil or plating is awful thin. So I'd prefer, if you just use the 2 watt, 20,000 ohm resistor, it really doesn't take a very long time, and this way it doesn't pre-damage the capacitor plating. You might reduce the surface area of the plating, and as you do that, the capacitor will be able to store less microfarads. And so this is just a safe, good way in order to be able to discharge it, and then we can go ahead and measure it. In this case, you can see the common is black, and the green is the fan, and white is the HRM. But most of the time you'll see these black capacitor tabs, and it'll say what the tab is right there on the side. So between common and HRM, it'll say whatever the rating is. In this case, it's 25. And between the common and the fan, on this one it'll be 5. And in this case, you'll see 45 plus 10. And so the 45 is between the common and the HRM, and the 10 is between the common and the fan. Now in terms of knowing what tabs to measure, here it's pretty simple, but it's often not that simple. And you can see there's corrosion on this one. So if you want to see which one's the C, which one's the fan, which one's the HRM, you can use non-soap steel wool and just kind of rub that rust off in order to see. And for something like this, you might not be able to clean it off and be able to see. So another way is by looking at the tabs. So you can see that on this one, you have the common right with the 4 tabs, the HRM has the 3 tabs, and the fan has the 2 tabs. So the fan always has the least amount of tabs. So on this one right here, you can see the fan must be this one right here. And on this one, there's only one tab on it, and so that one's the fan. And so right there you see 4 tabs, so that's the common, and that means that the 3 tab right here, that's the HERM. Similarly right here, this is the common, and that's the HERM. So same right here. So you can see the most is the common, the least is the fan, and the HERM usually has 3. So for the higher measurement, you check between the common and the HERM with your multimeter probes, and for the lower measurement, you check between the common and the fan. I'm going to buzz through these all real quick, and so they've all been discharged, ready to go. So I like to just measure inside these little holes that are there, and I like to just kind of twist my probes and to make sure that I get an accurate reading. So you can see this one's 0.46. So that's no good. Next one, this is a 40 plus 5. And so let's measure between the common and the HERM. 11.74, so that's no good. Between the fan and the common, that one's 5. So between the common and the fan, that one is still at 5 microfarads. So that 5 is good, but the 40 is no good because we measured 11. So you just replace the entire dual run capacitor. You don't usually stack 2 single run capacitors next to each other and jump between the common. If you absolutely needed to, you could, but we typically do not because we stock enough of these dual run capacitors in our truck. All right, this one right here is 13.4 and it should be 30. So you can see the plating on the inside is broken down. So we just don't have enough plating to store those electrons in order to have that extra storage capacity. Now this is supposed to be 5 and we're measuring 3.1. And so that one, once again, is bad. Now for our single runs, and this one's 7.5. We dig in, you want to make sure that you're kind of scraping in. So this one says it should be 7.5, we're measuring 6.35. So would the fan motor start? Yeah, the fan motor would start, but it doesn't have the correct amount of amperage on the start winding. And so the other thing is this capacitor is going to lose more and more plating as it gets older. So this one you would replace. You'd replace it if it's 6% or more away from whatever the target is. And you can see that it's actually too low. Here's another one at 5. And so these small ones are just for the indoor fan motor. That's what these tiny little ones are for. And so 3.57, and it should be 5. You want to replace these. These do not last that long. And so they will do damage to the fan motor if these capacitors are bad. So the fan motor is going to overheat, and there is a thermal limit on the inside of those fan motors, but it is going to cause irreparable damage to that fan motor. And so you want to replace these before that blower motor goes bad at the indoor unit. And as far as the outdoor unit goes, the fan motor seems to last a little bit longer when you have a bad capacitor, but you still want to, during preventative maintenance, replace them. And you want to replace them with a good capacitor, not a junk or cheap one. Just for the sake of checking it, here's a good one, our 45 plus 10. And so let's go ahead and measure between the common and the HERM. 45.1, so that's what it should be. Sometimes these tabs are rusted, and so you really need to break through the rust and kind of scrape and make sure you get a good electrical signal on this. So 10.16, so that's a good capacitor. This brand is a decent capacitor as well, so this one's good. So let's look at some capacitors that you don't even have to test. You're just going to replace them with a new one. So you'd replace them with the same microfarad rating, but an equal or higher voltage rating. And you can see that this one's a 440/370 volt capacitor, and most new capacitors are like that. So this one has a mushroom top, as you can see here, and you can see even the bottom, see, it's got a mushroom bottom. That means that it has overheated, and sometimes it'll even break off the common connections, so this one's automatically bad. Here's another one that has an extreme mushroom top, and once again, it's a dual run capacitor, and you know immediately that this is bad. Here's a single run, mushroom top, obvious that it's bad. here you have some leaky top. So you can see the oil that's leaking up through the top. And when you see that, when it's glistening like that, you know that that capacitor is bad immediately. Same thing right here. And this one actually had the fluid come completely out and leak down the side. So you know that this is bad as well. You're going to find capacitors like this, and so that have bad electrical connections. And so it's just rusty. And so it's going to draw excessive heat there, and it's going to break. So you would just go ahead and replace this as well. This is no good. You're not going to clean the tabs off. You're just going to replace this with a new one. These two right here are ones that you can't even find the ratings on. They're just worn off, they're rusted. And so if these are bad, which you don't even know what you're testing. So to know if these capacitors are good or are bad, and what the new capacitor measurements would be, you need to look on the side of the compressor. You're going to see the microfarad rating that's needed for that capacitor and the voltage rating. And if you don't see that, you can look up the model number online and go to that manufacturer's site, and you should be able to find the correct capacitor required. And similarly, on the outdoor unit fan, it's going to be on the side of the fan. And even for the indoor fan motors, you're going to see the capacitor rating needed on the side of the blower motor. So you're just going to replace that with what's required by that specific motor manufacturer. I hope this video helped, and if you want to learn more about HVAC, make sure to join our online HVAC Academy at acservicetech.com/academy. And we also have our second edition refrigerant charging and service procedures for air conditioning book available over at our store at acservicetech.com/store and on Amazon. This book is also in the course platform, and there's over 750 activities in here and 20 certificates just for that one course. But there's tons of courses in there. So if you want to learn about HVAC, make sure to join over at acservicetech.com/academy.